Good afternoon, everyone. Thank you all for joining today. My name is Alexander Amini, and I'll be one of your course organizers this year, along with Ava. And together, we're super excited to introduce you all to Introduction to Deep Learning. Now, MIT Intro to Deep Learning is a really, really fun, exciting, and fast-paced program here at MIT. And let me start by just, first of all, giving you a little bit of background into what we do and what you're going to learn about this year. Existed in reality. In fact, I want to start this class by actually showing you how we started this class several years ago, which was by playing this video that I'll play in a second. Now, this video actually was an introductory video for the class. It was this idea that I'm talking about. So let me just stop there and play this video first of all.
Hi everybody, and welcome to MIT 6S191, the official introductory course on deep learning taught here at MIT. Deep learning is revolutionizing so many fields, from robotics to medicine and everything in between. You'll learn the fundamentals of this field and how you can build some of these incredible algorithms. In fact, this entire speech and video are not real and were created using deep learning and artificial intelligence. And in this class, you'll learn how. It has been an honor to speak with you today, and I hope you enjoy the course.
So, in case you couldn't tell, this video and its entire audio was actually not real. It was synthetically generated by a deep learning algorithm. And when we introduced this class a few years ago, this video was created several years ago, right? But even several years ago, when we introduced this and put it on YouTube, it went somewhat viral, right? People really loved this video. They were intrigued by how real the video and audio felt and looked, entirely generated by an algorithm, by a computer. And people were shocked with the power and the realism of these types of approaches. And this was a few years ago. Now, fast forward to today and the state of deep learning today, we have seen deep learning accelerating at a rate faster than we've ever seen before. In fact, we can use deep learning now to generate not just images of faces, but generate full synthetic environments where we can train autonomous vehicles entirely in simulation and deploy them on full-scale vehicles in the real world seamlessly. The videos here you see are actually from a data-driven simulator from neural networks generated called Vista that we actually built here at MIT and have open sourced to the public, so all of you can actually train and build the future of autonomy and self-driving cars. And of course, it goes far beyond this as well. Deep learning can be used to generate content directly from how we speak and the language that we convey to it, from prompts that we say. Deep learning can reason about the prompts in natural language, in English, for example, and then guide and control what is generated according to what we specify. We've seen examples of where we can generate, for example, things that, again, have never existed in reality. We can ask a neural network to generate a photo of an astronaut riding a horse. And it actually can imagine, hallucinate what this might look like, even though, of course, this photo, not only this photo has never occurred before, but I don't think any photo of an astronaut riding a horse has ever occurred before. So there's not really even training data that you could go off in this case. And my personal favorite is actually how we can not only build software that can generate images and videos, but build software that can generate software as well. We can also have algorithms that can take language prompts, for example, a prompt like this. Write code in TensorFlow to generate or to train a neural network. And not only will it write the code and create that neural network, but it will have the ability to reason about the code that it's generated and walk you through, step by step, explaining the process and procedure all the way from the ground up to you so that you can actually learn how to do this process as well. Now, I think some of these examples really just highlight how far deep learning and these methods have come in the past 6 years since we started this course. And you saw that example just a few years ago from that introductory video. But now we're seeing such incredible advances. And the most amazing part of this course, in my opinion, is actually that within this 1 week, we're going to take you through, from the ground up, starting from today, all of the foundational building blocks that will allow you to understand and make all of this amazing advances possible. So with that, hopefully now you're all super excited about what this class will teach, and I want to basically now just start by taking a step back and introducing some of these terminologies that I've kind of been throwing around so far, with deep learning, artificial intelligence. What do these things actually mean? So first of all, I want to maybe just take a second to speak a little bit about intelligence and what intelligence means at its core. So to me, intelligence is simply the ability to process information such that we can use it to inform some future decision or action that we take. Now, the field of artificial intelligence is simply the ability for us to build algorithms, artificial algorithms, that can do exactly this: process information to inform some future decision. Now, machine learning is simply a subset of AI which focuses specifically on how we can build a machine to, or teach a machine how to do this from some experiences or data, for example. Now, deep learning goes one step beyond this and is a subset of machine learning which focuses explicitly on what are called neural networks and how we can build neural networks that can extract features in the data. These are basically what you can think of as patterns that occur within the data so that it can learn to complete these tasks as well. Now, that's exactly what this class is really all about at its core. We're going to try and teach you and give you the foundational understanding and how we can build and teach computers to learn tasks, many different types of tasks, directly from raw data. And that's really what this class boils down to at its most simple form. And we'll provide a very solid foundation for you, both on the technical side, through the lectures, which will happen in two parts throughout the class, the first lecture and the second lecture, each one about 1 hour long, followed by a software lab, which will immediately follow the lectures, which will try to reinforce a lot of what we cover in the technical part of the class, and give you hands-on experience implementing those ideas. So this program is split between these two pieces, the technical lectures and the software labs. We have several new updates this year in specific, especially in many of the later lectures. The first lecture will cover the foundations of deep learning, which is going to be right now. And finally, we'll conclude the course with some very exciting guest lectures from both academia and industry who are really leading and driving forward the state of AI and deep learning. And of course, we have many awesome prizes that go with all of the software labs and the project competition at the end of the course. So maybe quickly to go through these. Each day, like I said, we'll have dedicated software labs that couple with the lectures. Starting today with Lab 1, you'll actually build a neural network. Keeping with this theme of generative AI, you'll build a neural network that can listen to a lot of music and actually learn how to generate brand new songs in that genre of music. At the end, at the next level of the class on Friday, we'll host a project pitch competition where either you individually or as part of a group can participate and present an idea, a novel deep learning idea, to all of us. It'll be roughly 3 minutes in length, and we will focus not as much, because this is a 1-week program. We are not going to focus so much on the results of your pitch, but rather the innovation and the idea and the novelty of what you're trying to propose. The prizes here are quite significant already. Where first prize is going to get an NVIDIA GPU, which is really a key piece of hardware that is instrumental if you want to actually build a deep learning project and train these neural networks, which can be very large and require a lot of compute. These prizes will give you the compute to do so. And finally, this year we'll be awarding a grand prize for Labs 2 and 3 combined, which will occur on Tuesday and Wednesday, focused on what I believe is actually solving some of the most exciting problems in this field of deep learning, and specifically how we can build models that can be robust, not only accurate, but robust and trustworthy and safe when they're deployed as well. And you'll actually get experience developing those types of solutions that can actually advance the state of the art in AI. Now, all of these labs that I mentioned and competitions here are going to be due on Thursday night at 11 p.m., right before the last day of class, and we'll be helping you all along the way. This prize, or this competition in particular, has very significant prizes, so I encourage all of you to really enter this prize and try to get a chance to win the prize. And of course, like I said, we're going to be helping you all along the way. There are many available resources throughout this class to help you achieve this. Please post to Piazza if you have any questions. And of course, this program has an incredible team that you can reach out to at any point in case you have any issues or questions on the materials. Myself and Ava will be your two main lecturers for the first part of the class. We'll also be hearing, like I said, in the later part of the class from some guest lecturers who will share some really cutting-edge, state-of-the-art developments in deep learning. And of course, I want to give a huge shout out and thanks to all of our sponsors who, without their support, this program wouldn't have been possible for, yet again, another year. So thank you all. Okay, so now with that, let's really dive into the really fun stuff of today's lecture, which is the technical part. And I think I want to start this part by asking all of you and having yourselves ask yourselves this question of, why are all of you here? First of all, why do you care about this topic in the first place? Now, I think to answer this question, we have to take a step back and think about, the history of machine learning and what machine learning is and what deep learning brings to the table on top of machine learning. Now, traditional machine learning algorithms typically define what are called these set of features in the data. You can think of these as certain patterns in the data, and then usually these features are hand engineered. So probably a human will come into the data set and with a lot of domain knowledge and experience can try to uncover what these features might be. Now, the key idea of deep learning, and this is really central to this class, is that instead of having a human define these features, what if we could have a machine look at all of this data and actually try to extract and uncover what are the core patterns in the data so that it can use those when it sees new data to make some decisions. So for example, if we wanted to detect faces in an image, a deep neural network algorithm might actually learn that in order to detect a face, it first has to detect things like edges in the image, lines and edges. And when you combine those lines and edges, you can actually create compositions of features like corners and curves, which when you combine those, you can create more high-level features, for example, eyes and noses and ears. And then those are the features that allow you to ultimately detect what you care about detecting, which is the face. But all of these come from what are called kind of a hierarchical learning of features. And you can actually see some examples of these. These are real features learned by a neural network, and how they're combined defines this progression of information. But in fact, what I just described, this underlying and fundamental building block of neural networks and deep learning, have actually existed for decades. Now, why are we studying all of this now and today in this class with all of this great enthusiasm to learn this, right? Well, for one, there have been several key advances that have occurred in the past decade. Number one is that data is so much more pervasive than it has ever been before in our lifetimes. These models are hungry for more data, and we're living in the age of big data. More data is available to these models than ever before, and they thrive off of that. Secondly, these algorithms are massively parallelizable. They require a lot of compute, and we're also at a unique time in history where we have the ability to train these extremely large-scale algorithms and techniques that have existed for a very long time, but we can now train them due to the hardware advances that have been made. And finally, due to open source toolboxes and software platforms like TensorFlow, for example, which all of you will get a lot of experience on in this class, training and building the code for these neural networks has never been easier. So from the software point of view as well, there have been incredible advances to open source, the underlying fundamentals of what you're going to learn.
Artificial intelligence has ignited a fourth industrial revolution. What is AI?
Artificial intelligence is not really about intelligence. Artificial intelligence is simply the next wave of automation.
Artificial intelligence is already in huge ways making our lives better. When you get on an airplane and fly from San Francisco to New York, 99% of commercial air miles at this point are flown by a machine, not by the person.
AI gives us a clear shot at building self-driving cars that will transform transportation. I think we have a clear shot to transforming agriculture. I think AI will help doctors with diagnosis, with care of long-term health conditions.
The best doctor probably can do 60, 65, 70% accurate guesses looking at the screen. Machine now does probably 80, 85 to 90%.
Scientists can grow new bladders and new blood vessels and parts of hearts and even parts of lungs. Artificial intelligence will allow researchers to pick up on patterns that they couldn't otherwise do. It allow them to gather data and sort through the data much quicker than they would have been able to do with just their human brain.
Combined with robotics, artificial intelligence will transform manufacturing just as tractors changed farming.
One of the challenges of explaining the impact of AI is that it will change every single major industry. I think AI is the new electricity.
Artificial intelligence enables machines like robots to speak like humans, to see like humans, to play games like humans, to reason like humans, even to communicate like humans.
Quiet, please. I'm doing the talking.
I'm sorry. That's the most remarkable thing I've ever seen.
Mathematician John McCarthy coined the term artificial intelligence in 1955. He predicted that computers could be programmed to mimic human thought.
You are listening to the heartbeat of sage computing. Every instrument in this room is constantly testing, pulse-taking, controlling.
For decades, scientists pursued McCarthy's idea in vain. Then, in 1997, artificial intelligence came back into the news when IBM's Deep Blue computer defeated world chess champion Garry Kasparov.
Stunning development. Garry Kasparov has resigned the position. What a shock.
It was painful defeat in 1997, not just because I lost to a computer. It was the first match I lost, period.
I don't recall any particular point where he made a mistake that lost, a significant number of points.
I think it's outstanding scientific achievement.
The strongest chess players, including the world champion today, they are much, much quicker than machines.
Ladies and gentlemen, this is Watson.
Since then, computers fueled by artificial intelligence have gotten better and better at beating our champions.
I reached a certain conclusion after playing with machines, fighting machines, and working with machines. Any process that we can quantify with the machines, machine will do better.
3 critical developments finally made artificial intelligence practical. First, processing power became faster and cheaper. In 1985, the most powerful computer was the Cray 2. It filled a room, cost $35 million, and was blind, deaf, and mute. Today, smartphones process data 10 times faster, cost under $1,000, and can see, hear, and speak. Data storage improved as well. In 1956, IBM's best hard drive weighed 2,000 pounds and leased for $3,000 per month. It had a storage capacity of 5 megabytes. Today, a thumb drive has 200 times more storage and costs less than $5. Then, digitization made vast amounts of information available. Books, sounds, pictures, and data from sensors were digitized. Today, 4.6 billion cell phones around the planet feed the growing pool of data. 90% of all the recorded data in human history has been collected and stored in the last 2 years. The internet distributes this data globally, instantly, and at zero cost. But it took more than fast computers and digitized data to make AI real. The third essential element was a new type of computer programming called deep learning.
Hello, iCub.
Hello.
Who am I?
You are Tony.
And who are you?
I am a robot, and I am developing a sense of self.
Recently, a lot of the improvements in AI have been due to one type of technology called deep learning, or called an artificial neural network.
A traditional computer program cannot learn. It requires a detailed list of instructions. If the computer encounters something its human programmer did not put on the list, the computer crashes. Neural networks are different. Instead of following instructions, they write instructions. At the beginning, a human defines a goal and feeds huge amounts of data to the computer. The neural network then crunches that data to find the best way to achieve the goal.
For instance, if you give the machine the picture of a bottle of water, the machine will look at it and will compare the pixels in the image with the pixels in many other images of bottles of water that humans have previously tagged and said these are bottles of water. The machine doesn't know what do you do with it. Do you throw it? Do you eat it? Do you drink from it? It has no idea.
Neural networks recognize patterns in complex data, but humans teach the computer what to look for.
Think about it as if you had an all-powerful but somewhat dopey genie at your disposal. And you said, make me a peanut butter and jelly sandwich. And he shows up and he just drops the bread and a jar of peanut butter and a jar of jelly and a knife in front of you. And then you say, no, I want it as a sandwich. So then he's okay. And he gets out the piece of bread and he spreads some peanut butter on the bread, spreads some jam on the bread, and he puts them together with the peanut butter on the outside here and the jam on the outside here and slaps it down on the table. You're like, no. The peanut butter and the jelly have to both go inside because I don't want to get my hands all dirty. That's how a good sandwich is. Okay. That's how the jobs of the future are going to feel to most people. We're going to have computers that can do things we can't do, but we're going to spend our time, instead of doing the jobs are going to be too hard for us to do in many respects, actually trying to carefully specify what exactly we want them to do, because they don't care what we mean by a sandwich.
Artificial intelligence also makes robots smarter. Cameras and sensors have expanded the jobs robots can perform, and construction materials are stronger and lighter than ever.
Robotics puts computation in motion. Imagine a future where people would connect with machines in much more intuitive ways, where machines would be able to understand what people want. In that future, everyone will be able to use robots, just like everyone uses smartphones.
But is this vision of AI too rosy? Does AI have the potential to take over? Movies portray robots as thinking creatures bent on destruction. Warnings abound in the media.
We just don't know what's going to happen once there's intelligence substantially greater than that of a human brain. What do we do?
Full artificial intelligence could spell the end of the human race.
Some speculate about a point of no return called singularity.
Singularity is a point in time after which artificial intelligence has progressed so much that it's impossible to predict what's going to happen next. It's sort of this black box that we can't touch because we don't know what's coming. I'm not afraid of the singularity. I'm not afraid of it because I think that humans will be at the center of it.
You're not a bad dancer.
The public impression is that these machines are going to come, marry our women, and drink our wine. There is zero technical support for the idea that machines are going to become sentient creatures with their own independent goals and desires.
Part of the mystique of AI is its ability to learn from data, figure out new things by itself. But at the end, it is just a piece of software. Just because we're so good at building specialized intelligences, it does not mean that these evil sentient killer robots are anywhere on the horizon.
But that message does not sell movie tickets.
You had your time. The future is our world.
Catch!
Get ready for a surprise!
Why would they want to take over humanity? I have a different fear for us to have. What if computers become hyper-intelligent and want not to do our work for us anymore? They want to be like our dogs and cats and just lie on the couch all day. If you could run the world or just lie on the couch all day and have somebody else take care of you, which would you take?
Humans and machines are different. Humans seek new experiences. Machines don't. They have no imagination or intuition, and no one knows if they ever will.
People are very different. We learn from an example of one. We don't need to look at a million examples of what a bottle is in order to know what a bottle is and what to do with it.
One of AI's advantages is its reliance on data instead of intuition. Some companies now use performance data to decide raises rather than personal recommendations. AI can reduce bias, but if the data is flawed, AI can magnify errors.
They do not have common sense reasoning. They require a lot of training, a lot of data that is manually labeled by people. And even with that data, sometimes they make mistakes.
You can have the smartest and most reliable witness in the world, but if that witness were trained using completely faulty information and never was allowed to understand the variation between what that information was saying and how the real world works, you're going to get a biased opinion. So just as it's true that a very smart expert might give you garbage in, garbage out, all these technologies will give you garbage in, garbage out, potentially.
The negative side of all these neural networks having an impact is they can be stupid. They're not by default smart, right? It's like a little kid, right? Don't do that again, don't do that again. And so having people try to define and manage and weight all those things, that'll be a necessity.
History shows that all technologies have risks. Electricity was frightening at first. Thomas Edison electrocuted an elephant to show that while electricity could kill, it could also be made safe enough for a child. Once we learned to manage the risks, electricity brightened our world.
If you think of robots as artificial people that are coming to compete with us and take our jobs, that's not a helpful perspective. If you think of robots as the next phase of automation, just as the automobile was or the railroads were, then you get a very different perspective about what its potential benefits are.
AI and robots are tools that we invent, we create. They're tools by the people and for the people.
Cranes lift heavier objects than we can. Calculators are faster at math. Dogs detect smells better.
Nobody worries about the fact that an automobile can run faster than a human being, or that an ATM can count money more accurately than teller. We see those as advantages. We don't build machines to compete with people. We do not build machines to make our lives worse. We build machines to improve our lives.
AI is a tool that allows us to make decisions based upon extensive data instead of gut instinct. From driving across town to investing for retirement to undergoing surgery.
There's about 60 years worth of really solid research comparing human decision makers versus algorithms on exactly these kinds of important decisions. The results of that body of research are incredibly clear. For heaven's sake, take the algorithm.
As computers, which are levers for our minds, and robots, which are levers for our bodies, make it possible for us to move larger boulders, as Archimedes would say.
AI and robots will perform all kinds of tasks we would rather not do ourselves, or that make us more efficient.
Our guest today is Daron Acemoglu, and he will help us shed light on these questions and on what policy can do to build on the promises and mitigate the risks of AI. Daron is the Elizabeth and James Killian Professor of Economics and also an Institute Professor at the MIT. He was awarded the John Bates Clark Medal in 2005. Among economists, that's a greater honor than a Nobel Prize because it is only awarded biannually to a single person in the field. By some measures of citation counts, Daron is actually the most influential economist in the world. Let's stay in the realm of work, but focus on working conditions as opposed to incomes. So this includes, for example, questions like worker monitoring. What do you view as the main potential benefits of AI in this space, and what are the main potential harms?
That's a great question. I think, first of all, it's a great question because it's a perspective that's sometimes often missing from economics and also from public discussion. That, you know, a job is not just an income stream. It's a meaningful social activity. We define ourselves by the thing that we do because we spend the majority of our waking time doing those activities, our social networks, our role in society. All of those are defined by our job. So a job is a very, very important social construct. And in that context, you have to recognize what are the things that people value about their jobs. Well, the social networks, the self-worth, the autonomy, the sort of the sense that we are doing something useful. I think all of those are very, very important. And I think sociologists and anthropologists, for example, have recognized how disruptive social and economic changes are when they rob people of these meaningful, symbolic aspects. So there's a huge literature, for example, that shows how Native Americans got completely pushed into almost group level depression in many cases because their most symbolic and meaningful social activities, hunts, the way of celebrating things, etc., were robbed from them by European settlers and Americans. So you have to think about, what are those aspects of jobs that we have to think about? And autonomy, I think, is a very important part of it. And being worth something because we are contributing something unique is part of it. So in that respect, well-designed AI and automation can help. If you ask workers who are in well-managed automating manufacturing firms who have survived and who have, not lost their job, they actually love the robots because the robots have increased productivity and they have taken some of the hardest and most dangerous jobs away. And if the company is well run, and not many of them are, but well run, they also manage to save the workers from the robots who can actually chop your head off if you get to them too close. But so if it's managed well, some of the most routine, boring, uninteresting jobs can be taken away by algorithms and machines, and that would be good. But in fact, if you look at how AI is being used, in addition to automation, a very common use of AI is for monitoring workers. And this monitoring often takes the form of not helping the workers, but completely robbing them of autonomy and making them work excessive hours. So Amazon, on paper, is a great employer, right? It pays a much higher wage than Dunkin' Donuts or Wendy's or Walmart. But many employees don't like Amazon. Why? Because Amazon is at the forefront of using data and AI-based processes to monitor workers, collect huge amount of information, and actually make them work very hard. So it gets very efficiency, but not by making them more productive, but making them work harder. So there's a couple of publications that collected data. I don't think they're completely representative, but they collected data on injury rates at Amazon. And they're very, very high by industry standards, and they spike up during periods of peak work, like holiday season. So that is just the tip of the iceberg about how little autonomy is left because of this monitoring. And I think if that monitoring continues unabated and unmonitored itself, or forgive the pun, it's actually going to change the nature and social meaning of work in very important ways. And it's also going to have major effects on income distribution because monitored workers cannot ask for higher wages.
So based on these observations, what would be the one or maybe two main policy measures that you would recommend?
Well, I think, again, this is such a new area that we have to be a little bit cautious in policy. How do you distinguish between the good use of data and bad use of data? Or if I tell you I'm your customer, I'm your employer, and I'm collecting data so that I help you to become more productive, but actually I use that data in order to monitor you. So it's a very, very gray area, but there are at least some minimal things that we just absolutely must abide by, which currently Amazon or other employers are not. We should never collect information and use information about individuals without their consent. Right now, nobody knows in the Amazon workforce what Amazon collects information about and how they're using that for promotion, for firing, for setting the work requirements for you. We should also have some basic standards like safety and autonomy, that individuals should not be turned into, more flexible robots. Again, where are the boundaries of that? Of course, if I am your employer and you're my driver, I can ask you to drive from point A to point B without taking a 2-hour lunch break and then visiting point C on the way. But, is it reasonable for me to say you should drive the fastest possible way, the fastest possible rate, as if there is no traffic when there is actually traffic, so that you actually have to go over 80 miles an hour in order to make that time requirement? So those are all gray areas. I think they have to be part of the public debate and public policy, but I don't have a custom-made discussion, sort of policy recommendation about where to draw the line on some of these issues.
Thank you. Now, you have also spoken about the ability of AI systems to collect and process vast amounts of data about its users, its consumers. What are the potential benefits and downsides to all this data collection and data processing?
Well, I think this actually gets to the heart, in my opinion, of what I call disrupt existing balances. You know, my view has always been that human societies, when they function even to a moderately acceptable level, they are based on a number of balances. You know, the employer's power has to be balanced against the power of employees, the state's power against that of society, different political parties, within family, between groups in social interactions. And I think the biggest problem of the data economy is that it's disrupting these balances. It is empowering companies against their citizens, and it's empowering states, against their customers, companies against their customers, and states against their citizens. And those two are lightning rods for me. They are very dangerous developments. We are there perhaps, or will be there soon, but many companies will know more about you than you know yourself. That sphere of private domain where I make my decisions, I have autonomy, I have something approaching free will, that will all become meaningless. But worse, the same thing for the state. The state will know so much about its citizens. How can you do dissent? How can you do protest? How can you generate new ideas when that's the case? When your boss knows so much about you, how can you be innovative? So I think there are a lot of intersecting questions there. Now, those are the bigger questions. And I think we are going in a very unhealthy direction, precisely because AI is doing the bidding. Our current AI research is doing the bidding of a few very large companies who are amazingly expansionist in their vision. So these are not companies like some of the old big companies like GM that want to sell you a lot of products. They are much more like Standard Oil that want to control everything. You know, Standard Oil was such a threat to American livelihood and democracy, not because it was making a lot of money, it was, but it also wanted to control the entire economy. It wanted to control the whole transport system, even when it was run by other companies. It wanted to completely be in charge of the whole industrial structure because it was controlling the lifeblood of industry. And it was actually exploiting that. So I think current big tech mindset is worse than Standard Oil. So therefore, it's really feeding into this, using information for empowering companies against customers. And then, you know, the economics of it, so that's like the broader social thing. Economics of it doesn't work out either. So privacy. You know, how can I have privacy when you are collecting so much data from all the people that I know, not just from me? So, you know, the privacy debate is like framed as, oh, well, you know, consumers can opt out of things and they can protect their data if they don't really want to. Well, it doesn't actually work that way. Data is the lifeblood of many AI applications. AI cannot be thought without abundant data. And some of the good uses of data, AI, really depend on that data. So if you want to cure cancer, again, no chance of that using AI in the next several decades, in my opinion, but we can make progress. But if you want to make progress in that, you need to have a lot of data about what different types of symptoms and what different types of behaviors are associated with different onsets and developments of cancer. So that means you take a lot of data and pool them. But the problem is, once you have that capability for collecting a lot of data and pooling them, then I can collect a lot of data about you from your friends, from things that are correlated with you without your consent. And that really throws the whole system into disarray.
Mm-hmm. Let me perhaps ask, are there any specific regulatory solutions that you propose with respect to data, perhaps in the realm of privacy?
Yeah, I think we have to strengthen the privacy requirements, but we also have to sort of revive consumer protection. What do we need? What do we mean by consumer protection in the age of data and AI? Ralph Nader, for example, before he became a third-party candidate disrupting the political system in the US, was a hugely important political figure because he had a defining role on how we perceive of consumer protection. What happens when you get faulty products? What happens when safety is not prioritized in cars? So that was not a very well-defined problem before Ralph Nader started, doing the public advocacy and revealing data about what was going on. So I think we need to do the same here. We need to understand how it is that these companies are using the data and which are the ones that are acceptable and which are the ones that are not acceptable. I personally don't find it problematic that Amazon gives me recommendations. But there might be other things that I find quite problematic about what Google knows about me. So I think we have to decide which ones individuals generally find problematic, but don't have the agency to deal with it. And that's where public policy as a regulatory system has to come in. On the other side, and in contradistinction to it, we also have to find ways of making data more available to other competing companies. So you see that these two objectives are contradictory. One says protect the consumers, especially their privacy and what you can do with data. But the other one says, now if Anton collects data about Daron, and Anton's competitors should also have that as well. So these two are both very important because if we don't do one of them, the consumer is ill-treated. But if we don't do the second, this time Anton gets to have an artificial monopoly because he's the one who got there first and started collecting too much data about me. So we have to solve both of these problems, and you cannot solve one without the other. Why? Because if you don't have a good privacy infrastructure, you cannot make that data available. So you have to solve both of them at the same time.
Thank you, Daron. Now, in your paper, the final category of potential harms from AI were harms to democracy. And I should emphasize to our audience that Daron has not only contributed groundbreaking works to economics, but he is also the author of 2 books at the intersection of economics and political science, together with James Robinson. The Narrow Corridor from 2019 is a book in which they argue that liberty requires a very delicate and precarious balance struck between the state and society. Now, in your research, Daron, you're making the case that AI, as practiced by many of today's leading social media platforms, is contributing to echo chambers and other adverse effects that undermine our democracy. I cannot help thinking of the Facebook files, for example, in this context. And additionally, it also exacerbates the Big Brother effects that allow autocratic governments to suppress dissent from their citizens. Can you explain in a little bit more depth what this is about? And in the spirit of balance, what could AI systems actually do to enhance our democratic societies?
Well, first of all, thank you again. And on this one, I think I am in good company. There are a lot of other people who have, over the last 3 or 4 years, have woken up to this danger and have written some at high level, some with more data, and I'll mention a few of them. But just let me start from the last part of your question. It's actually ironic. The first wave of thought on the effects of digital technologies, internet, on democracy was completely the opposite. In the early 2000s, everybody and their dog thought that we were entering a new era of openness, democratic journalism, democratic dissent being much easier because everybody could write on wikis and we could use the internet to monitor corrupt politicians. And of course, I think today, nobody clings to that view anymore. But it's not because that view was fundamentally wrong. It is because that view would have required a very different direction of technological change and a very different balance of power. Once the internet was recognized, once data was recognized as an important resource by authoritarian governments and companies, they had much more resources to control the technology. So a good example was the Iranian Green Revolution. So when students, youth, and some workers rose up against Ahmadinejad's incompetent dictatorial regime, at first they were using modern social media. Even though the Iranian state is not at the forefront of technology, they had enough resources that once they poured their resources, they could turn the tables on them. Now they use the internet and all of the existing social media to catch all of the protesters and throw them in jail. And it's a cautionary story, which is, again, much better told perhaps via the lens of China, of what I call Big Brother effects, that now, what George Orwell feared in 1984 seems like child's play. So the amount of information that you can collect about somebody who uses social media, if you're a government or intent on doing so, is just enormous. So that really strengthens all sorts of governments, authoritarian and non-authoritarian one, against their citizens. It's quite clear what the implications are if you're China or Iran. But I don't think the implications are going to be any more innocent if you are USA and NSA. So that sort of balance is completely out of the window when the government can collect so much information. And there are a lot of different problems that this creates. Dissent becomes much harder. Opting out becomes much harder because now opting out becomes a signal. So if everybody is using a browser that government can track very well and they see that you cannot be tracked, that must be using Tor. If you're using Tor, you must be a dissenter. So there are a lot of second round effects that all help the powerful governments. Now, that may or may not be the more important problem, but the one that actually has afflicted the US more recently is Facebook. So Facebook, I think, is not unique to Facebook, but is emblematic of what the particular business model of many of these tech companies is doing. First of all, Facebook, like Google and many others, has a business model that's ad financed or ad monetized. So that means that they have to maximize engagement. And in order to maximize engagement, they have to feed you things that are going to get you hooked, that often tend to be more sensational stories that are going to create either echo chambers or artificial sort of reactions. And they can do that with micro-targeting. So then you see the two parts of the business model. One is maximize your hooked nature to the platform, how much time you're going to spend impulsively on the platform. The second is complete disregard for your privacy so that I can collect as much information about you and I can micro-target things that are going to make you hooked or pull you into an echo chamber and get the biggest reaction from you. And that's very specific to Anton. If it was for Daron, it's something else. If it's for Megan, it's something else. So that we have seen, if it's unregulated, can be quite disastrous. There was a huge amount of extremism fed through all of these social platforms. Some of them have cleaned up their act a little bit. Like Reddit was one of the worst, and they started cleaning up. YouTube actually was horrible. YouTube's feed early on, once they started introducing AI-based recommendation system, was keeping a lot of young people hooked and then taking them more and more to extremists, websites. So, you would listen to somebody complaining about woke culture. They didn't call it woke culture 8 years ago, but something like that. So then they would feed you a video by Jordan Peterson, and then you listen to Jordan Peterson, and they would feed you an alt-right one, and soon you were listening to neo-Nazis. And you see that's a public policy problem. Lots of young people being indoctrinated into alt-right or neo-Nazis is not an individual choice that we can say, oh, that's a consumer choice that it's between the company and the individual. So those are the issues that we really have to sort of worry about. And again, requires a much deeper dive into public policy. What do we expect from social media? Do we set a much lower standard for them than traditional media, which is what we're doing right now? In fact, we subsidize what they do often. So, or do we actually understand all of their broader social effects? And look, again, there's nothing about the nature of AI per se. The early ideas that AI could empower dissenters, journalists, etc., that could have been true, but it required a different path of technology. So what we can do with AI, we can go back to those aspirations. We can try to develop AI much more like Tor, or much more like differential privacy or encryption that protects individual autonomy, protects individual privacy, protects dissent. We're not doing that. We're not going to do that when Google, Facebook, or Amazon make the choices. So that's where we need diversity of approaches.
Thank you, Daron. So we've been through a whole range of areas related to AI, and unfortunately, we are already in our last 6 minutes. So let me ask you, what broader lessons should we draw for the need for AI regulation? And perhaps also, to what extent would competition help or hurt us with the problems that you're describing?
Well, let me actually start from the second part of your question, because I think, you know, if you are an economist, if you look at the current landscape, you know, it looks like a monopoly, smells like a monopoly, quacks like a monopoly. You know, you have these huge companies, and they are dominant in their sectors. And now we haven't taken action against them because of a stupid criterion that was propagated by people like Robert Bork and others, which is that you have to prove almost beyond reasonable doubt that a monopoly creates harm to consumers. So that's why we have approved a lot of mergers, or US courts became very company friendly. So therefore, if you're an economist, your first instinct might be, and I applaud that, well, let's get rid of this Borkian tradition. Let's tackle these monopolies with antitrust. And there are some economists who are finally waking up to that, and there are some legal scholars who are finally waking up to that. And now Lina Khan is in charge of competition policy, and she is a big advocate of using antitrust. I applaud that, but I think it's completely inadequate, because we're not really dealing with a monopoly problem. Monopoly is part of the problem, but we're not dealing with a monopoly problem. You know, the antitrust tradition in the US goes back a long time, but one defining person is Louis Brandeis. And he was writing at the age of trusts, where really the problem was a monopoly problem. Standard Oil was using its control of the US economy in order to charge higher prices. And moreover, with the regulatory state that existed at the time, there was nothing else other than antitrust, using the Clayton Act and the Sherman Act that they could have used. But today, we are not dealing with a monopoly problem. We are dealing with something much more pernicious. I've pointed out what this is doing to our democracy, to the future of work, to the citizens' information, to privacy, to misinformation. None of those you're going to fix if you get these companies to charge lower prices. In fact, in many cases, they're not even charging prices anyway. They're just making money from ads. So you need a much more expansive way of dealing with it. So I applaud the anti-big tech sentiment. I think that's much needed. But we have to channel that the right way. And I think the right way to channel it is to really think of a broader regulatory framework. So let me try to amplify that point for 30 more seconds. Say, for example, if you have the narrower vision of what to do with regulation triumph, and we break up Facebook into WhatsApp, Instagram, and Facebook proper. Perhaps it helps, but most likely it won't, because all three of these companies will still have huge effects, and they will have exactly the same business model. And some of them may become even more extreme, less self-restrained, in order to grab market shares from others. So what we need is a complete overhaul of their business model and a complete change in the direction of technological progress. None of this you're going to automatically achieve by competition policy. So that's why we need a broader debate. And as part of that broader debate, we need to really develop much better ways of regulating what these companies do, what their power is via information, via control. And we have to have a much more robust approach to redirecting technological change.
Thank you, Daron. Now, let me ask one final question. In light of the problems that we have just been discussing, one temptation is to feel overwhelmed by the magnitude of all our challenges and just throw in the towel, but that seems hardly like the best course of action. So I would like to ask you if you have one actionable piece of advice for the members of our audience, many of which are active in policy circles, what would it be?
Well, actually, I'm a huge believer in the importance of discourse. When the tone of the discourse changes, everything changes. Let me give you a small example. 3 years ago, it seemed like it would be crazy to expect any new public policies from the government in terms of fighting poverty and supporting children in financial difficulty. Today, US has actually lower child poverty rates, and it is possible that we'll pass legislation that will actually help poor families with children tremendously by a variety of levers. How did this become possible? Because suddenly the discourse changed. So the future of technology is all about discourse at some level. So the first thing we have to do is change the discourse. The current discourse is AI is wonderful. AI is going to give you everything you want. You have to let AI decisions in the hands of the people who know best. And everybody else, all these activists and all these citizens, you don't understand AI. You don't understand its promises. Just stay away from it. That's the discourse we have accepted. That's the discourse New York Times has fed you. That's the discourse that, you know, the Democratic Party as well as the GOP are completely on board with. And I think that discourse has to change. Sure, you and I and the activists are not going to know how to best design an algorithm, but we sure need to be consulted if that algorithm is going to catapult our lives and is going to collect huge amount of data about us and is going to impoverish us. So the consequences of these new technologies are things that we all have to have a say on. And that's the change in discourse that we first must go through first. And that's where I think we can all make a difference.